Okay guys, so we're going to start our unit on circles today, and we're going to start with chapter 12. Like I told y'all in class, this is going to be very definition heavy in this section. There's going to be a lot of rules, there's going to be a lot of theorems. The problems aren't going to be super hard that you're going to come across. The algebra is not going to be bad, but you are going to have to go through and make sure you're looking over those definitions and terminology. Okay, so we're going to do 12.1, and we're going to start with just some definitions of circles and some properties that go along with them. So a circle is the set of all points in a plane that are equidistant from a given point, okay, which is going to be your center. This is basically what you guys will see for your notation. It'll be a circle with a little dot in the middle to call that circle C, okay? The interior is going to be the set of all points inside the circle. The exterior is the set of all points outside the circle. All right, so some new terms for you guys. A chord is going to be a segment whose endpoints lie on a circle. Okay, chord AB. A secant is a line, not a segment, a line that intersects a circle at 2 points. So you can see secant L here. A tangent is a line in the same plane that intersects at exactly 1 point. So it basically just touches it right there at the edge. That's going to be called your point of tangency, the point where it intersects. So let's go through and just identify a couple of these. We want to identify each line or segment that intersects circle A. Okay, and note the notation so we can get used to that. So your chords are going to be, notice my notation here, not line EF, segment EF. This is the kind of mistake that's going to happen on your test, you guys, I'm going to be looking for. All right, also, do you see another chord? BC, which is also your diameter. Okay, secant. Now, notice the difference between your secant and your chord. Secant is a line, so secant is going to be line EF. This, again, you guys, is something to note, because that's where the small, tiny mistakes are going to happen. Your tangent is going to be line L. We can just call that guy line L. Diameter is going to be BC. Okay, segment BC. And then your radii are going to be AB and AC. And notice they're both segments. Okay, so you guys can say AB, AC, you can say BA, CA. All right, but again, note that they're line segments, not lines. All right. Okay, couple more terms, you guys, like I promised. So, two circles are congruent if and only if they have congruent radii. Okay, and just note the notation here, you guys. Okay, circle A is congruent to circle B. All right, but I would just kind of make these notes that I'm underlining here. This is something that you're going to know. Concentric circles are coplanar with the same center. Okay, so they're not congruent. They're coplanar with the same center. Okay, if they were congruent, it would be the same circle. All right, and then two coplanar circles that intersect at exactly 1 point are called tangent circles. Well, you can remember that because we just talked about our point of tangency. All right, so notice you kind of internally, it would be worth doing these drawings for these guys here so you can understand what you're talking about. All right, internally tangent, okay, this is going to be the center here. They're touching at exactly 1 point. Externally tangent, these are the centers, and they're intersecting at exactly 1 point. Okay, so once you understand tangency, this falls into place. This is something that we need to make sure we're good with. Okay, so we want to identify the tangents of circles. We want to find the length of each radius, identify the point of tangency, and then write the equation of the lines. We're going to deal with vertical or potentially horizontal lines here. You guys will see vertical in these examples. So, circle A, the radius, here's the center of circle A, 1, 2, 3, 4. Circle B, okay, here's circle B, 1, 2, your radius is going to be 2. what's our point of tangency, guys? I'll put POT for point of tangency. Where are they intersecting? 1, 2, 3. This is going to be a point. 3, 0. All right. And then look at this line. It wants us to write the equation of the tangent line. Okay? Well, what's your equation of your tangent line? Vertical line, x equals 3. So you guys will have some examples like this in your homework. And again, this is just kind of playing around with the terminology here. A couple more things, guys. So a common tangent is a line that is tangent to two circles. All right? And if you think about the words, that makes sense. Okay? Here's your point of tangency here. All right? A line that's tangent to two circles. Okay? So lines L and M are common external tangents to circles A and B. All right? Now, let's look at these points here. These guys are on the outside here. These guys are crisscrossing over. Lines P and Q are going to be common internal tangents to circles A and B. Okay, so common tangents, they're tangent to two circles. All right, last theorems that we're going to deal with. We have 3 of them. So if a line is tangent to a circle, it's perpendicular to the radius drawn to the point of tangency. All right, so I would just write this down, you guys. If a line's tangent to a circle, the line's perpendicular to the radius. Okay, and here's your converse. If a line is perpendicular to the radius of a circle, then the line is tangent to the circle. Okay, so again, this is what I would write down. So 2 theorems, one's the converse of the other. So basically, if you have a point tangent, if you draw a line straight to the radius, that is going to be perpendicular. Our final one, and this is what we're going to use for our next example. If 2 segments are tangent to a circle from the same point, okay, then the segments are congruent. It's like a little hat, like a little party hat sideways, or however it's oriented. So again, this is what I would write down. 2 same segments are tangent to a circle from the same exterior point, the segments are congruent. Alrighty, and again, this is what we're going to use. So this is the kind of material that we're going to be getting into where you guys have to remember all those rules and how you're solving for x and putting these different problems together. Okay, so let's look at this example, guys, and we'll wrap it up. So it tells us that segment DE and DF are tangent to circle C. We want to find DF, okay, so we're looking for this segment length here. This is D right here, guys. I guess I covered it up a little bit. All right, so based on what we just said, these guys are going to be tangent to each other, so we can set up our equation. So 5y minus 28 equals 3y. We can solve for y, subtract it over and add it over, and you get y equals 14. Okay, what are they asking for? Not y. They may, but in this case, they're asking for df. All right, so 3 times 14 is going to give us 42. Okay, so the measurement of df is 42. And of course, DE would have to be 42 as well. So if you guys put 14 in here, you're going to get 42 as well. So really, theoretically, it doesn't matter which equation you plug it into, but just to be clean, we're plugging it into DF. All right, guys, so this is the homework that we're going to be working on in class on Wednesday.